This is Lisa. In this video, we'll be talking about graphing equations in two variables. If you want to graph the equation of a line, you must find at least 2 points that are solutions to the equation. If you have 3 points, you can verify that they do indeed line up. So I always recommend finding 3 points when you're graphing a line. First, create a table and choose either x or y values to find the points. Plot the points on a graph, and then draw a straight line through the points. So let's do some examples. Example 1 in your workbook says, graph the following lines. 3x plus 2y equals 12. So I need to create a table of values. So this is what we did in the last section. In the last section, however, in the workbook, you already had values plugged in. Here you need to choose some values. You can either choose x values or y values. And I choose values very close to 0 because I don't want to be graphing numbers like 100 on my axis. So I'm going to pick x values in this example. X is 1, x is 0. If you would like to, you can choose a y value. If I choose y equals 0, it means I'm trying to find that x-intercept. Also a very nice point to find. So let's do the first line. If we let x be -1, we have 3 times -1 plus 2y equals 12, or -3 plus 2y equals 12. To solve the equation for y, I need to add 3 to both sides of my equation, which gives me 2y equals 15. And if I divide 2y by 2, it'll leave me with y equals 15 over 2. Now, the true value here is 15 over 2. I can plug that into my table, but oftentimes when we're graphing, it's easier to do this as a decimal. If you divide 15 by 2 on your calculator, it will tell you it's 7.5. So if I want to locate that point on my graph, I go -1 in the x direction. So here's -1 in the x direction, and 7.5 in the y direction is going to be in between 7 and 8. So if I find where that point goes at those two values, x is -1 and y is 7.5, I'll get that point right there. I always recommend to students that they label their points. And if we do the second value in our table, we said we were going to let x equal 0. So 3 times 0 plus 2y equals 12. 3 times 0 is 0, so we can ignore that. 2y equals 12. Divide both sides by 2, and we get y equals 6. So now we're looking for the point 0, 6. 0, 6 happens to be our y-intercept. And our last point that we said we were going to find was when y equals 0. So 3x plus 2 times 0 equals 12. 2 times 0 is 0, so we can ignore that part. 3x equals 12. Divide both sides by 3 to solve for x, and we get x equals 4. So 4, 0 would be our x-intercept. Go to 4 on the x-axis and 0 in the y direction, and here's our point. And now sometimes they don't line up perfectly, but they're reasonably close to where they should be. So if I draw a line that goes through these points, do they reasonably line up? And the answer here is yes, because I noticed I plotted one of my points wrong. This should not be here. That's 7. If I count my tick marks, 1, 2, 3, 4, 5, 6, that point was supposed to be at 6. It was supposed to be 0, 6, and this one was 4, 0. So my points do line up. I have graphed the equation 3x plus 2y equals 12. Let's do a couple more examples. Y equals 3 halves. Remember, equations that only have one variable are our special kinds of equations. If we draw our chart, this one, the only thing the equation tells us is that our y value has to be 3/2. It helps you to put lines across it to make your table. 3/2 is the same as 1.5. And in this, it leaves the x values completely open. My equation doesn't tell me anything at all about x. I can choose whatever values I like for x. I can have -3, I can have 1, I can have 4, I can choose whatever numbers I want to. But again, remember, you're graphing these, so smaller numbers are a lot nicer to work with. If I go to -3 on my x-axis and then up 1.5, there's my point, -3, 3/2. 1 in the x direction, up 1.5, there's my point 1, 3/2. And 4, 1.5, or 4 3/2, there's my point there. And then if I try to draw a line, can I get a line to go through those points? Yes. And what kind of a line is this? This is what we call a horizontal line. Okay, horizontal lines are the ones that go straight across. And here's my goofy little trick for students. I say if you write your H's kind of fancy, if I turn it upside down, what letter does it look like? It looks like a Y. Horizontal lines only have the letter Y in their equation. So that's my goofy little trick for the day. Let's look at example number 3. Example number 3, this time we only have x in our equation. X plus 5 equals 0. When we have only one variable, we always want to get that variable by itself. Plus 5 means I'm going to do -5. I get x equals -5. My table of values, my equation again, only gives me a restriction on my x values. X is always -5. So what can we choose for y? Any numbers we want to. Let's do 1, 2, 3. Makes it easy. If I go to -5 in my x direction and I go up 1, there's -5, 1. -5 in the x direction, up 2 in the y direction, there's -5, 2. -5, up 3 in the y direction, there's -5, 3. And can we tell what kind of a line we're going to get? We're going to get a vertical line. I'm off a little bit there, but I get this time a vertical line. Vertical lines are equations that are x equal to some number. Our vertical lines only have the letter x in their equations. Example 4 says we have y equals 3x. We have both y and x. We know this is not going to be vertical or horizontal. We know that it's going to slant this way or this way. And a little bit later on, we'll be able to determine exactly which way it goes. So that's kind of what you're looking for when you look at that equation. I'm going to start off with a chart. Notice this one is already solved for y, so I'm going to pick x values to stick in. -2, 0, 1. If I plug in -2, I get y equals 3 times -2, or y equals -6. If I plug in 0, y equals 3 times 0, or 0. And if I plug in 1, 3 times 1 is 3. There I have filled in my table of values. I can plot those 3 points. One other thing I wanted to point out to you, in this example here, this is the only time that the x-intercept and the y-intercept are the same point. The only place on the graph where the x and the y-axes cross are at the origin, the point 0, 0. So So there's one of my points, 0, 0. Another point was -2, -6. Now, my graph doesn't go all the way down there, so I can just add another little mark there and say this is -2, -6 would be located right about there on my graph. And 1, 3 is here. And I'm telling you, I'm cheating right now. I'm using an index card because that's what I happen to have handy to use as a straight edge. So I hope this looks straight. I'm not drawing that by hand. No freestyle there. And my points again line up. So I have the graph of a linear equation, right? Linear means it's going to be a line when we graph it. Let's look at the last example, number 5 in this section. Here we're given a graph. The graph shows the value of a photocopier over the first 10 years as a function of its age. Using the graph, give an estimation of the depreciation during the 5th year. Okay, so if we look at this graph, okay, the graph shows, what did it say? It shows the value of a photocopier over the first 10 years. Okay, so when I look at this, it's over the first 10 years. The x-axis represents the years, and the y-axis represents the value. And it didn't specify this, so I'm going to assume it's in dollars for the value. Okay, so when we look at it, we want to know the estimation of depreciation during the 5th year. Okay, so during the 5th year, what is our photocopier worth? Well, here's our 5th year, and if we go up, there it is. Okay, and we go over, it's $1,500. Okay, so we're looking at the graph. Given an x value, we're trying to find the corresponding y value. And this video will end now. You should be ready to do section 5.2 homework, followed by the quiz. Have a great day, everybody.